There's some new joint types as well. There's 4 new joints: the orientation, parallel, inline and in-plane, and the name already indicates what type of joints they are. So they're basically enhancements of the general joint. So remember that joints internally, they are just relations between degrees of freedom, but they have been set up here just to make it user friendly, so that for example, if you define a parallel joint, it automatically creates a local coordinate system where in this case 3 translations are free and 1 rotation is free, and then the 2 other rotations are fixed. For instance, that's a parallel type of definition. So internally it creates relations between degrees of freedom, but it just makes it easier for the user to define a certain type of behavior. Now, there's actually now a delete part, believe it or not. It sounds maybe a little bit trivial that you can actually delete a part, but in the past you just had to suppress it if you wanted to delete it from your simulation. Now you can actually delete it, and that could be handy if you have very large models which you want to reduce, you want to make them a bit smaller and delete parts, or for instance, if this model has to be sent to a customer and it's a confidential model and certain parts need to be deleted from the model, you can do it this way. Just right click and delete it. Okay, there's a new name selection definition through a contain operator. So the whole idea is, if you have a very large model and you have organized your model in a set of name selections. So here, for instance, you can clearly see there are some name selections where the first 4 are called something like face front 1, face front 2, etc. So they're all clearly linked to the front of the structure, and there's some other name selections related to the back. So what if we want to pick up all the faces that are basically included in all the name selections at the front? Well, we now create a new name selection, so we add all the faces which are basically in the name selection that contains the name front, and that just means that it will go through all the name selections and pick all the faces that are in the first 4 and you do a Boolean operation, add them all together in a new name selection. And another thing with name selections is there's now a right-click go-to option. Now you may already know that the right-click functionality is quite powerful. For instance, with context, I personally use that a lot, where you basically select a few bodies in the model and then right-click and find all the contexts corresponding to those bodies, or even more powerful when you select 2 bodies and then you right-click, find all the contacts common to those bodies. So basically you find a contact between these bodies. You can do something similar now with name selections. So you can basically select a few entities in the viewport and then right-click and then go to the name selections that either contain that current selections or that basically contain selections that are common to what you have selected in the viewport. Alright, if you have surface models, shell models, typically defining a thickness is done traditionally on geometric definition. So you have to basically break the model in the preprocessor, like the design model or space claim or the CAD package, and then you traditionally assign the thickness on the surfaces per surface. But what if you just want to quickly try out something, maybe make some local elements a bit thicker, or you don't want to go back to space claim and imprint or break a surface? You can now very quickly add a thickness definition underneath the geometry. So again, this is for surfaces where you just quickly change the thickness of local elements, one element or a set of elements, and try out a few different scenarios. Staying with shell elements, I mean, you may know shell elements, they typically have bending and membrane behavior, so they are used for thin-walled bodies, and they're two-dimensional surfaces which have rotational bending stiffness as well. So that makes them really powerful to model, thin-walled bodies like cars and planes and trains, etc. They have now also allowed you to define the stiffness behavior for flexible shells and take away the bending behavior, so basically take membrane behavior only, or stress evaluation elements only. So that means, for instance, if I have a large solid structure, I could create a skin of shell elements around the solid body and just give them stress evaluation behavior only, which means I can use them for post-processing and look at detailed stresses on the free surface of a solid body. Or if you want to define just membrane behavior like a trampoline or a balloon or something like that, then you can define that here as well.